Welcome to Displaced Thresholds. I'll be facilitating this module today. My name's Michael Morris and I'm a trainer and assessor with AMS Australia. This module is for educational purposes only. Now, by definition, a displaced threshold is a runway threshold located at a point other than the physical beginning or end of the runway. In other words, it's shortening of the runway from the arrival end. Why do we displace a runway threshold? Yeah, a runway threshold may be displaced from the extremity of a runway if the obstacle limitation surface is infringed by an obstacle, the PANS-OPS airspace is infringed by an obstacle, or an immovable object or structure extends above the approach surface. The main reasons a threshold may be required to be displaced are an obstruction in the approach surface, a runway unserviceability. Now, this runway unserviceability has to be located at the end of the runway for us to carry out a displaced threshold. Now, the runway unserviceability could be due to an unserviceable runway surface or a disabled aircraft located at the end of the runway. Now, displaced thresholds could either be permanent or temporary. Now, permanent displaced thresholds are due to permanent obstacles infringing the runway approach surface. Now, these obstacles may be either natural or man-made. So as cities and towns grow and develop, airport operators are under constant pressure to maintain their protected airspace. So bridges, buildings, exhausts, and communication towers are the main reasons for permanently displacing a runway's threshold. This is an example of what one wouldn't class as a permanent obstacle. Could be classed as a transient obstacle, being the train. But because the train can't be controlled, therefore stopped before the sides of the approach surface, the aerodrome operator has taken the steps to permanently displace the threshold, therefore ensuring the constant serviceability of the approach surface. Now, at Brisbane Airport, runway 01 right became permanently displaced by 60 metres after the construction of the Gateway Bridge. So the Gateway Bridge was built after the runway, and due to the height, it infringed on the obstacle limitation surfaces, being the approach surface for the 01 right end. The world's longest displaced threshold is located in India. It has a single runway of 0422, it's 3,290 metres long, and has a displaced threshold of 1,140 metres at the departure end of runway 04. Departures are only possible on runway 22 due to the large hill sitting at the end of runway 04. Temporary displaced thresholds may be required to accommodate works on the end of our runways, or to continue reduced runway length operations during a disabled aircraft incident. If a runway threshold is temporarily displaced, the aerodrome operator must assess the revised approach display for the OLS and notify in writing to CASA of any new obstacles, recalculate the TOTA, the critical obstacle gradient, and the STOTA in the reciprocal direction, and report any changes resulting from the recalculations to the AIS provider and raise the appropriate NOTAMs. So the reason why we displace the threshold is to protect our obstacle limitation surfaces. The aerodrome operator has a legal obligation under Civil Aviation Safety Reg 139 to protect the airspace from infringement by obstacles and thus minimising the risk to aircraft operations. The airspace associated with an airport is that which aircraft use to effect their arrivals and departures. This involves not only the airspace immediately above the airport, but also that above a sizable area of surrounding land over which the airport operator has no control. So obstacle limitation surfaces, for those that haven't conducted the module, look like this. So any obstacles on or in the vicinity of an airport, whether they're natural features, man-made structures, or high exhaust plumes, may prevent its full utilisation by aircraft. Their presence may reduce the range of weather conditions in which the airport could be used, reduce the runway lengths available for landing and takeoff, and therefore the types of aircraft that can use them, limit use to aircraft with appropriate performance capabilities, or impose limits on passenger numbers or possible destinations so that some operations may not be economically viable. The approach surface is the surface within the OLS that's going to be impacted. So the approach surface is an inclined funnel-shaped plane which originates 60 metres before the runway threshold. The approach surface may be divided into 3 sections, and the overall length of the approach surface can extend up to 15,000 metres. Here we have a diagram, an overview of the approach surface, the overall length. We've got a cross section which will identify the first section, the second section, and the horizontal section of our approach surface. Now, if we're going to calculate our approach surface, we have to identify what type of runway we have. Are we a non-instrument runway? Are we an instrument runway? And based on our code of runway, will give us the parameters and the characteristics of our approach surface. So our approach surface will be referred to as a slope factor. Our approach surface sits under our 3-degree approach slope, which aircraft take to meet the touchdown zone. But as we know, our obstacle limitation surface originates 60 metres from the end of our runway, or at the end of our clearway. So depending upon the percentage of our approach surface, will give us a slope factor. So if we've got a 5% approach surface, we have a slope factor of 1 in 20, all the way to 2%, which will give us a slope factor of 1 in 50. So we have to determine what the slope factor is based on our percentage of our approach surface before we can carry out any calculations. So we're going to go through 2 scenarios. Scenario 1, we're going to deal with an obstacle within the approach surface itself. So in this screen we have a downward view looking at our approach surface, our runway strip, and our runway. This is a serviceable approach surface and it's a serviceable runway. We have a look at the side view. We have identified our 3-degree approach slope and our approach surface. We do have buildings, man-made structures and natural structures that sit below our approach surface, but our approach surface hasn't been infringed and therefore it's serviceable. So down the track, we have possibly a developer come in and he clears some land and he decides to build an apartment block. Now, in order to build that apartment block, he's gone through legal channels and got approval to build up to a certain height, which ensures that he's not infringing on the airport's approach surface. Now, in construction, in order to get materials up to the top of a apartment block or tower, requires a crane. Now, the height of most cranes aren't taken into consideration when the approval process is going ahead. But by having a crane placed on top of an approved structure, we now no longer have an obstacle-free approach surface. We therefore don't have a serviceable runway. So if we do have obstacles infringing the OLS, we immediately have to remove that obstacle. If the obstacle can't be immediately removed, then we need to close the runway. We can close the runway by using markers, unserviceability crosses. We would have to raise a NOTAM to state that the runway was closed. Then we'd have to calculate or conduct a calculation to be able to displace the threshold. And we'd also have to calculate what our new declared distances are for both runway ends. We would then carry out the displaced threshold by putting in the required markers or markings depending upon the length of time that obstacle is going to be there. Then we could reopen the reduced length runway. So how do we calculate a displaced threshold? We have to identify the maximum operating height of the obstacle. Now this isn't just the operating height, this is the maximum height that that jib can reach. We not only have to take consideration of the height of the obstacle, but also the terrain that that obstacle is sitting on. For this example, the height of the obstacle, total height is 8 meters. We then have to calculate the slope factor of the runway. Slope factor is the approach surface. In this example, we have a slope factor for a non-precision Code 3 runway of 2.5%. That gives us a ratio of 1 in 40, or a slope factor of 40. We have to measure the distance of the obstacle from the clearway. The clearway is identified with the use of our gable markers or large white cones. For this example, the distance from the clearway is 120 meters. So our calculation is the height times the slope factor plus the distance, which gives us a total of 440 meters. That is how far we're going to have to displace the threshold to maintain a safe approach surface. So if we have a look at this diagram, we've now displaced the threshold. So we've changed the approach surface. The approach surface originates much further down the runway to clear the new obstacle. Our runway threshold is now identified with the use of markers, or V-bar markers, which are placed either side of the runway. And by doing so, we're maintaining a safe approach surface, and we're maintaining a safe 3-degree approach slope. What we need to also take into consideration are our declared distances. So our declared distances from this end of the runway are going to have to be recalculated. Our takeoff run available, our landing distance available, our STOTA, or supplementary takeoff distance available, are all going to have to be calculated and republished. The same goes for the opposite end. We'll have to recalculate all of our declared distances based on the new runway lengths. Scenario 2 is a disabled aircraft on the runway. Now here we have an example of a serviceable approach surface, serviceable runway and runway strip. So say we had an aircraft land, blew a tyre, rolled to the end of the runway. He now can't be moved. He's disabled. Now whilst it doesn't impact on the approach surface, any aircraft that try and land at that end could collide with the obstacle that's sitting on the runway end. So we would carry out a displaced threshold using a calculation. We'd measure the height of the obstacle. Now the maximum height in this scenario would be the aircraft's tail. The tail height for this example is 4 meters. We measure the slope factor of the runway. We'll use the same slope factor of 40, and we measure the distance from the runway clearway. So what we have is the height times the slope factor plus the clearway length, which gives us 220 meters. This is a different scenario because we now have an unserviceable portion on the runway. We're still using our V-bar markers to identify the new threshold, but we now have to place unserviceability markers. Those unserviceability markers are identifying the edge of the new clearway, and being that we may have workers or mechanics to try and rectify the disabled aircraft, we've also placed out works limit markers. Prior to reopening the runway for reduced length operations, we're going to have to calculate our new declared distances. Our new declared distances from the arrival end of the displaced threshold and also the departure end of the opposite reciprocal. The markers that are required to identify a displaced threshold. V-bar markers are markers that are used to identify a displaced threshold for less than 30 days. The pattern and the size of V-bar marker required is dependent upon the width of runway to be displaced. So if you have a runway width of 18 metres or less, you only need to use one V-bar either side of the runway. If you have a runway width of more than 18 metres, you need to use a double V-bar on either side of the runway. Existing gables can be used for the bar part of the marking, and flat panels could be used for the V's. The V-bar markers are placed on both sides of the runway, and the markers may need to be weighed down or secured to the ground, so they're not blown around by weather or impacted by jet blast. Refer to MOS 139 Chapter 8, Division 3, 8.29 in regard to markers required for a displaced threshold. Markings used to identify a displaced threshold. Well, markings are things that we paint. So if a runway is going to be temporarily displaced for more than 30 days, then V-bar markings must be used. Existing runway markings need to be removed or painted over. And in this example, we've had to paint out our runway end marking, our runway threshold and piano keys, and our runway designator. Refer to MOS 139 Chapter 3, Division 3, 8.27 for markings used to identify a displaced threshold. So if a runway is going to be permanently displaced, then new markings must be provided. We have to repaint the threshold markings or the piano keys. We have to reinstate the runway designator, and existing runway centre lines could include an arrowhead pointed towards the new threshold. Refer to MOS 139 Chapter 8 Division 3 8.26 for markings used to identify a permanently displaced threshold. If your runway has PAPIs, which are precision approach path indicator lights, then these need to be deactivated. The PAPIs are there to identify the touchdown zone or the 3-degree approach to the runway's touchdown zone. So if we've displaced the threshold, the touchdown zone is no longer located in the same position, therefore the PAPIs need to be deactivated. All other runway lighting systems within the closed or displaced portion of the runway must also be deactivated or covered. This can include the runway threshold lights, runway edge lights, runway centerline lights, and touchdown zone lights. We can use lighting to identify a displaced threshold. Now, temporary lighting can be used, and they are green lights placed on both sides of the runway in line with the bar part of the V-bar marking. Now, for a runway width of more than 30 metres, 5 green lights either side of the runway need to be used. And for a runway width of less than 30 metres, then 3 green lights on either side of the runway can be used. If the runway has circuit operations, the innermost light may be fixed and omnidirectional. The outer 2 or 4 lights must be fixed and unidirectional. Other lights used to identify a displaced threshold could include a runway threshold identification light. These are white strobe lights located either side of the runway. These could be used by day or night to mark the temporary displaced threshold of a runway that is not servicing scheduled international air transport operations, and may be used in lieu of temporary displaced threshold V-bar markings. For more information on runway threshold identification lights, refer to MOS 139 Chapter 9, Division 10, 9.59. Lighting used to identify the new runway end from the opposite end. So by displacing the threshold, the opposite runway end may also be affected. If the runway end location is moved from its original location, then the new runway end will have to be identified. The new runway end can be identified with the use of temporary runway end lights. Runway end lights are red. This is an example of identifying both the runway and the threshold if they're co-located. The aerodrome operator will have to resurvey his approach surface. So in scenarios 1 and 2, we identified that the start of the inner edge of the approach surface had changed. It had moved further down the runway. It's critical that the approach surface be resurveyed to identify any obstacles infringing the new approach surface. So on the left-hand side, with the original approach surface, we may have had a crane which fell outside of the divergence or the approach slope, therefore wasn't classed as an obstacle. But by moving the approach surface further down the runway, that crane is now an obstacle within our approach surface, which is providing a non-safe approach and therefore an unserviceable runway, which we may have caused by carrying out a displaced threshold. It's also going to have an impact on our departure and approach procedures. So by displacing the threshold, we're having an impact on the approach point. Now the approach point is where the pilot begins his 3-degree approach to the runway. We're also going to have an impact on the touchdown zone point of our approach procedure because we've moved it further down the runway. So if we have displaced the threshold, we'll have to contact our approach procedure designer. In this instance, it's IDS. Normally, it could be Air Services Australia, but we'd have to contact them to ensure that a new approach procedure could be drafted. So the impact on our RDS, or our declared distances. We have declared distances that need to be recalculated for both runway ends. A NOTAM must be raised to advise the aerodrome's amended declared distances. So based on the scenario of why we displaced the threshold, that's going to have an impact or could have an impact on our declared distances, our TOTA, our ASDA, our TORA, LDA for each end of the runway. We have to recalculate what those new lengths are and publish those lengths via a NOTAM. So just to recap, the types of displaced thresholds. We could have permanent or temporary. Calculating the displaced threshold based on the height, the slope factor, and the distance, the markers and markings required to carry out a displaced threshold. Lighting or temporary lighting required to identify a new displaced threshold. The deactivation of any lights within the closed or displaced portion of the runway. And the importance of resurveying our obstacle limitation surfaces. And the direct impact on our declared distances and approach procedures. And NOTAMing, or raising a NOTAM, and advising of our amended declared distances based on our calculations. I hope you've enjoyed our displaced threshold module, and if you do have any questions, you can advise or call the phone number that's listed on your screen now. Thank you for your time.